Last video I described how you can modify a clock to bypass the quartz crystal that usually regulates the ticking and install an Arduino or other microcontroller to directly drive the mechanism instead. Now that means you can do things like use an app on your mobile phone to make the time start or stop, or to control the speed at which the hands move. But there are some limitations. Clock mechanisms are designed to only rotate in one direction, clockwise. And even though the hour, minute and second hands rotate at different speeds, you can't move them independently. They're all driven by the same gear chain. So in this video, I'm going to demonstrate some other interesting things you can do with clocks by replacing the mechanism completely. Now in this clock, I've inserted a dual shaft stepper motor. This is a Glucon X10506, which is a stepper motor specifically designed for use in analog clocks on the instrument panel of a car dashboard. It has two shafts which you can attach your hour and minute hand to, but just like the regular clock mechanism I just showed, there's still only one gear train. So the shafts always rotate in synchronization with each other at a ratio of 12:1. Every time the minute hand moves through a full 360-degree rotation, the hour hand moves forward 30 degrees, or 1/12 of a rotation. But where it differs from the quartz clock mechanism I showed previously, this one has two coils. So rather than just applying a current across a single coil designed to make the rotor cog turn clockwise only, here we can explicitly control the direction of rotation by activating those coils in a specific sequence. This is the activation sequence for those two coils that makes the minute hand move forward 1 minute, or 6 degrees of rotation. The hour hand has an additional 12:1 gearing ratio, so every time the minute hand makes a complete revolution, the hour hand advances 1 hour. So I removed the original clock mechanism completely and instead installed the X10 stepper motor in its place. That's wired to an Arduino Nano on the side here, which is what sends that sequence of pulses to the two coils of the stepper motor every second. I also installed this toggle switch on the top, and when I flick that switch, it makes the Arduino Nano reverse the sequence of pulses, which makes the clock hands rotate anti-clockwise rather than clockwise. Which is kind of neat, but it's still got all the other limitations. I still can't control the hands separately. In order to do that, I'm going to have to make a different modification. Now Glucon do make other stepper motors with more features, such as their X40 model, but they're quite a lot more expensive. They're about €18. So I'm going to use one of these BKA30D stepper motors instead, which you can buy for only a couple of dollars on AliExpress, etc. You can also find this same design advertised as a VID28. Now again, it's a dual shaft stepper motor with two coaxial shafts designed to show analog indicators on a dashboard. But unlike the Glucon X10, this is not specifically intended as a clock mechanism. These two shafts could be used for any kind of indicator. So they have separate gear trains and can be controlled completely independently of each other. Now you'll also see it's a little bit chunkier than the X10. So instead of mounting it in a carriage clock, I've inserted one into a wall clock here. And now you can see it in action. So the two shafts have the same gear ratio as each other, where sending a pulse makes them rotate 1/12 of a degree around the clock face. So by sending the appropriate number of pulses, you can precisely move each hand to any one of 4,320 steps around the face of the clock. By controlling the rate at which the pulses are sent, you can get fairly granular control over the speed and acceleration of the hand's movement. And because each shaft has two coils, you can flip the order in which each coil is energized to make the hands rotate in either direction to get there. Now, this does mean it's a little bit more complex to wire up. Two shafts, each having two coils, which you have to connect both ends to, means that you need to use a controller with 8 GPIO pins. But if you look at the activation sequence on the datasheet, you'll see that the second and third contacts are always driven together. So they can share the same output, and in fact you only need to use 6 available GPIO pins. Now on the software side, I recommend using the Axel Stepper library, which makes it really easy to write Arduino code to set the position, speed and direction of the hands. Now, just a few final tips to give you. The shafts on all these mechanisms are very narrow, typically somewhere between 1mm and 4mm in diameter, which means that mounting the clock hands onto them can be a bit of a pain. Now, if you have a 3D printer, this is an ideal situation to print your own clock hands, or to print some little push-fit adapters that you can place onto the ends of the shaft to help attach the hands onto the mechanism. Now, the motors themselves are normally designed for mounting onto a PCB. You can see that the contacts are actually very, very thin front-facing here. Now, you can solder directly onto them, but it's a little bit fiddly. So if you're able to, you might prefer to create a PCB to attach the mechanism onto instead. And that's what I've done here. Now, the data sheets for both the X10 and the BK30D specifically say that they can be powered directly from a logic level output, and they draw less than 20 milliamps, which means you can power them directly from the GPIO pins of an Arduino or a Wemos rather than needing a motor driver. Now, I'm using a Wemos D1 Mini here, which is an ESP8266 based board. One of the advantages of this is it has built-in Wi-Fi, which means you can remotely connect to the clock and set the time from another device. I used the MIT App Inventor site to create a very simple app that lets me set the location of each hand, which it then sends as the parameters to an HTTP GET request to a web server running on the D1 Mini. And that's also what I used to create the app with the start-stop buttons and speed slider in the earlier example. And that's it. I hope you found this information useful, and hopefully you'll be able to think of a playful way to use clocks in one of your projects in the future. If you'd like to see more examples of playful technology projects, please do like and subscribe to this channel. And otherwise, I just want to say thanks very much for watching, and I look forward to seeing you next time. Okay, cheers, bye.